Here, we're going to look at Chapter 5 for Math 129. Here we're going to continue with our dimensional analysis, but we're going to look at how to convert from one system to another. So from our metric system to our household system. We can see here from our table some different conversions between the metric system and the household system. As the note says, you do not have to have these memorized, as they'll be on the formula sheet provided to you on the test. We also have some other conversions here with our liquid conversions, such as 1 teaspoon to 5 milliliters. Some of these will not be provided to you, although I highly recommend memorizing these first two, as they will make our lives a little bit easier. So things you do need to have memorized are all of the metric conversions. We saw them in Chapter 4, where you can use your decimal bumping or your dimensional analysis. And then our time. Most of this you'll probably be familiar with. Just make sure you're refreshing your memory on anything you forget. So let's look at an example. It says a patient received 2 teaspoons of Robitussin in 1 day. How many milliliters of the drug did the patient receive? So if we look at the two tables that we had before, we can see that having that 5 milliliters to 1 teaspoon memorized is very much going to come in handy here. I'll start out with my 2 teaspoons, and I'll say that in 1 teaspoon, there are 5 milliliters. When I cancel out those T's, I am left with my 10 milliliters for my final answer. So it's nice and easy one step if we have that memorized. Let's look at this. It says an infant weighs 4,200 grams. We're going to convert this to pounds and ounces. So we've seen things with 2 units before, like when we were looking at an infant's weight. Now we're going to look at how to actually do that conversion. So I'm going to start with 4,200 grams. And the first thing I'm going to try to see is what conversions do I have for my weights. And it appears that those conversions right here are limited to our 1 kilogram is 2.2 pounds. So the first thing I'm going to do is go from grams to kilograms. I know that there's 1,000 grams in 1 kilogram. Then I can use the conversion provided to me, that in 1 kilogram, there's 2.2 pounds. Now, I'm going to do this multiplication out, even though they ask me for pounds and ounces. So I'll do my 4,200 times 2.2 to get me 9,240. I have 1,000 in my denominator. When I divide them out, that gives me 9.24. And I always want to double check my units. Grams canceled out, kilograms canceled out. So all I'm left with is pounds. The issue is they asked us for pounds and ounces. So the 9, this whole number part, is what's going to stay my pounds. That 0.24, the leftover part, is what I'm going to use to find my ounces. So I'm going to treat that 0.24 pounds as a new dimensional analysis problem and convert it to ounces. We know from Chapter 4 in our household system that in 1 pound, there's 16 ounces. So when we multiply that 0.24 times 16, we'll end up with 3.84 ounces. So if they asked us for an exact answer, they told us not to round, we would say that it's 9 pounds and 3.84 ounces. Normally what they'll ask is for us to round to the nearest ounce. So if we did that, we'd have 9 pounds still, but that 8 would tell us to bump that 3 up to 4. So in our regular answer, what they would usually ask for is our 9 pounds, 4 ounces. If we look at another example, it says a patient is 6 feet 6 inches tall, and it asks us what the height is in centimeters. So essentially here we're going backwards. They gave us the measurement in two different units, the 6 feet 6 inches, and they're asking us for the height in centimeters. If we look at our measurements for length, we know that 2.5 centimeters is 1 inch. Now, this is one where you have to be a little careful. Our book uses 2.5 centimeters is 1 inch. And if you look at your formula sheet, we say that 2.54 centimeters is 1 inch. So I'm going to work with the one on our formula sheet, that 2.54 centimeters. Be careful when you're doing your homework on MyLabs Plus, as they tend to use the conversions from your textbook. So keep your textbook handy when you're doing your homework. Now notice, this conversion only deals with inches. So I'm going to focus on that 6 feet first and convert it to inches. I know in 1 foot there's 12 inches, and that's on your formula sheet if you don't have it memorized. And that gives us 72 inches. But this patient was not only 6 feet tall, they were 6 feet 6 inches tall. So I'm going to take that 72 inches and add the 6 extra inches that this patient had. So this patient is really 78 inches tall. Now I'm going to use my dimensional analysis to convert this to centimeters. So I know in 1 inch there's 2.54 centimeters. And if I do this, 78 times my 2.54 gives me my 198.12 centimeters. They did not tell me to round anywhere, so I won't. But if they did ask me to round, I would round appropriately. If we keep going, we have another example. It says a neonate's head circumference is 415 millimeters. We want to find the circumference in inches. Now remember, to get from the metric system to the US system, or our household system, we know that there's 2.54 centimeters in 1 inch. So the first thing I'm going to do is go from millimeters to centimeters. Then, once I'm at centimeters, I can go to inches. So if we think about our King Henry died Monday drinking chocolate milk, I know we're measuring meters, so I want M's after everything. And we could say I've got 415 millimeters, and I want to go backwards to centimeters. That tells me that I need to take that 415, my decimal point at the end, and go 1 space to the left. So I have 41.5 centimeters. Then I can use my 41.5 centimeters in my dimensional analysis and say there's 2.54 centimeters in 1 inch. When I multiply straight across, that gives me 41.5 over 2.54. My centimeters cancel out, so just inches. And when I divide that out, I end up with a very long number. I end up with 16.3385 and 8268 inches. But if we look up at the problem, they told us to round to the nearest tenth. That's 1 digit after my decimal point. So I know I'm going to have 16.3 inches as my final answer. Now I could have also done this whole thing in dimensional analysis. I could have started out with my 415 millimeters. And then I could have said, from my knowledge of the metric system, or using our King Henry died Monday drinking chocolate milk acronym, that I know there's 10 millimeters in 1 centimeter. And then our millimeters would cancel out, and we'd say that in 1 inch there's 2.54 centimeters. So our centimeters cancel out. If we do that, we'll have 415 over 25.4 inches. And if we do that division, we end up with the same exact long number, that about 16.338, and it keeps going. But that 3 tells us to leave it 16.3, and we know our units are inches. So as long as you're showing your work, you're okay. Now let's continue looking at what happens when we have a drug label or a carton. So they ask us here, determine the number of grams of pseudoephedrine in the entire container. So here we do need to be a little careful because this is a combination drug. So if we look, our pseudoephedrine sulfate is at 240 milligrams. And we know from our knowledge of drug labels that that's how much is in one tablet. And if we look here, there's 15 tablets in the container. So I'm going to start out with 15 tablets per one container. And then I'm going to say that in one tablet, I know there's 240 milligrams. I knew to put my tablets diagonal from each other so they would cancel out. But we want our final answer in grams. So I know there's 1,000 milligrams in 1 gram to get my milligrams to cancel out. When I multiply across the top, 15 times 240 gives me 3,600. In my denominator, I have 1,000, and when I divide them out, I end up with 3.6 grams. Now notice we still have that container in the bottom. So we can put that in words and say there's 3.6 grams per container. We have another example to look at. It says the order for a patient is Robitussin syrup, 10 milliliters by mouth every 4 hours. How many ounces of Robitussin would the patient have received by 10 p.m. if the first dose was administered at noon? So I'm going to have to be careful here with our 10 p.m. and our noon and our every 4 hours. So our patient got their first dose at noon. And I'm going to list out, my 1 p.m., 2 p.m., 3 p.m., all the way down to 10 p.m. to figure out how many doses they should get. If they're getting this every 4 hours, then at 4 o'clock, they'll get their second dose. At 8 o'clock, they'll get their third dose. And then they won't get their fourth dose until after 10 p.m. So we know that they're getting 3 doses. That's going to help us because if we just base it on the hours, we would assume that the patient would get 3.5 doses because of that 9 o'clock and 10 o'clock. So we need to figure out exactly how many doses the patient is actually getting because it's not continuous. So let's look at this again. They're getting 10 milliliters by mouth every 4 hours, and we want to know how many ounces of Robitussin the patient would have received by 10 p.m. So we know that there's 10 milliliters in every 1 dose. We know that the patient is getting 3 doses. The other issue we need to do is convert those milliliters over into ounces. And if you look at your formula sheet, you'll see that there's 30 milliliters in every 1 ounce, or fluid ounce, depending on how you prefer to write it. If we multiply straight across, we'll end up with 30 over 30 ounces, or we find that the patient gets 1 ounce, or you could write 1 fluid ounce instead. And that's it